Hello, ladies and gentlemen. Welcome to our first virtual lesson here in biology. I'm Mr. Adamucci. It's our first time doing this, so we'll see how this goes. I have no idea how it will go, but I think it will be helpful for you because as you watch the videos, feel free to pause them. Feel free to go back at any time. Also will be coming around, so if you have questions, you can ask me as you're going through these and read along as I go, as you have the paper in front of you. These are on YouTube, so you can watch them at home, anywhere you need to get a refresher. And we're first going to talk about a hypothesis, which is a testable prediction that we have about an experiment we want to run. Scientists, we're curious. We're curious about how something works, and we want to know what makes something work and if it's true or not. So let's say I'm talking about, I don't know, plants, okay? And let's say I have a bunch of plants and I want to know if fertilizer will work well on the plants. What I do then is I make a hypothesis. So I will say, if we grow plants in fertilizer, comma, it's an if-then statement, and our if is where we set up the experiment. Then, we then say the word then, the plants will grow. And I make a prediction here. Will they grow faster or slower? I could say they'll grow faster. Okay? I think with fertilizer that they'll grow actually faster. That's my prediction. It's an easy prediction. And can I test it? Yes, I can test this. So this is a correct hypothesis. Once I've tested, I can begin to set up my experiment. And there's different variables that you have to know. And make sure you understand hypothesis at this point. If you don't, you could pause it and go back and go over hypothesis if you need to with our if and then statements, and that they're testable predictions. It should be a little bit of a review for you. And then what I do is I then go into my variables. And there's certain variables that you have to know. There is the independent variable, the dependent variable, our control variables, and our control versus experimental group. And I'm going to go over each of these and what they mean. Okay, and this will help you do your assignment today. Independent variables are variables that we have control over and we choose to manipulate. So if I'm looking at plants and I'm thinking about fertilizer and changing up the fertilizer on them to see if fertilizer works, my independent variable that I'm manipulating is my fertilizer. For example, I might have a plant, I might have 3 different plants. In one of the plants, I might only put 2 scoops of fertilizer. In another plant, I might do 4 scoops of fertilizer. And then in another plant, I might do 6 scoops. Okay? This is my independent variable. It's independent of the experiment that's being run because I'm picking how many scoops of fertilizer to put. So that is my independent variable because I do not measure those. I'm manipulating them. So that's independent. Let's look at dependent, okay? And in dependent, what goes on there is we are measuring something, and it depends on the independent. Where the independent is independent of our experiment, the dependent depends on what we're measuring. Kind of confusing there, independent, dependent, they sound very similar. But your dependent variable depends on your experiment, it's what you're recording. So you might have to do some studying of this and listening to this video over and over to try to understand that when we have fertilizer, we're then going to measure the what of our plant. We want to see if they grow fast, so we're going to measure the height. And our height can vary, it could change. So this is what we are measuring. What we are measuring. So the height is our dependent variable. Height. Our fertilizers are independent and our dependent variables are height because it's what we are measuring. We then look over at control variables. And control variables are variables that we have control over that we do not change. They stay constant. variables stay constant in all groups. In other words, in our plant with 2 scoops, in our plant with 4 scoops, in our plant with 6 scoops, we will have some variables in there that we want to keep the same. Well, what do we want to keep the same? Basically, if we have a correct experiment, we keep everything the same except for the fertilizer, okay? Everything else should be the same. We only want to manipulate one variable so that we know that it was fertilizer that caused the plant to grow well, not the water or the sun. So, for example, we're going to keep water the same. So water is a control variable in this experiment. We want to keep sunlight the same. That's going to be a control variable, okay? We want to keep our soil the same. That's going to be a control variable. There's always a lot of control variables, okay? We want to keep soil the same as well. So soil, water, sunlight, anything else that you can think of that's the same through all the groups will be our control variable. We'll also have a control group. And your control group allows you to compare something to your experimental group. In these groups, we're experimenting 2 scoops, 4 scoops, 6 scoops. But we're also going to have a plant with how many scoops for it to be controlled? 0 scoops. That's our control group, okay? So we know that it was the fertilizer that caused the plant to grow and not something else that caused. So if our 0 scoops plant grew the same as our fertilizer plant, we can rule out that fertilizer helped. But if our 0 scoop plants barely grows and our 2, 4, and 6 scoops grow really fast, we know that our 0 scoops is our control group, and we compared that to our experiment. So we can compare. That's your control group, a plant with 0 scoops. Same with other experiments. If you had an experiment with smokers, and you said, does smoking cause lung cancer? Okay, and you can have an hypothesis. If somebody smokes for 30 years, then their chances of getting lung cancer increases. You would need to have a control group of people that do not smoke to see if they get lung cancer as well. So you can conclude that it's actually smokers that increase their risk of getting lung cancer. So we have our control group as well. Okay. In review, you have your independent variable, which is independent of your experiment. It's what we are manipulating. So that was our fertilizer in this case. You have your dependent variable, which depends on the height. Depends on what's being measured. And in this case, it's the height. And you have your control variables, which stay the same and constant throughout the experiment. That could be such as water, soil, and sunlight. Your control group is what you're comparing to. And that is something that you can compare your experiment to. So it has something that is 0 scoops in this case. So we can see that does our fertilizer actually work. Okay, so best of luck to you. Remember, you can pause, you can rewind. If you didn't understand any of this, it's okay. I'll be coming around to try to help you. All right, as you get the activity and try to figure out your independent control and your dependent variables. Okay, as we get biology going. Work hard, give it your best, and good luck to you.